discussing with respect to architectural level things, and then slowly moving into the knowing the each and every entity that is involved in the architecture, and then after that, at the end we'll be discussing something like scenario-based discussion, uh, uh, like what is IMS session, how it will start and how it will end, and even registration related call flow also we are going to discuss. That's it. Now let's begin the session. Okay. So before just beginning the IMS session, let us have uh, some kind of discussion or on some kind of lecture or on 2G related 2G or 3G or 4G related networking, network architectural level stuff, so that the people will be clear who are very new to this thing, that where actually uh, the IMS network is going to sit. This is what is the packet data side and what is subsystem data side. So just in case, just for the people, such people, that's it. Okay. So let's start. Okay. Everything in a network, like whatever the end user will be using, is nothing but just a device. This device is nothing but a mobile handset, whichever you are using it day by day. But based on the capabilities um, of the phone or the device, you will be availing certain kind of services. See, say for example, the phone whichever you have is some kind of low-end phone which is supported only 2G network. Okay, then it doesn't mean that uh, it just says that you have the protocol stack, 2G protocol stack got um, available in the unit. Okay, in the sense in that particular device. And there are phones that has got little moderate level capabilities like 3G related services, um, and which has got like services like video call, um, Skype, sessions, and like fast browsing, and all these things. So there are the features are going to be increased based on the capabilities of the phone. How the where you are going to scale, with what perspective you are going to scale the capability of the phone. Basically, here it comes two parts. One is the type of network, and another one is what is the bandwidth. Okay, so the type of network is, if it is 2G, that itself it says that you have um, uh, there are certain constraints involved for the applications to achieve the quality of service. In the sense like over on a 2G phone, if you are expecting to establish a video call, um, certainly it is possible, but the quality of that particular video call is very, very, very good. It is going to be very, very, very good. But when it comes to um, the services like normal, simple, plain text-based web page browsing and all, yeah, it can be possible. And with respect to those services, yes, to certain extent, the quality of service will be good. And uh, so when it comes to different kind of services, based on the services, the type of network is also going to get changed. Okay, like if you have 2G, you will have only certain set of services. If you have 3G, you will have more number of services. If you have 4G, you will have still more number of services. say for example in 2G you have only like browsing and voice call, to certain extent low quality video call. But in 3G you have voice call and as well as browsing and as well as um, high quality video call with some other supplementary services like Skype and all can be installed, and YouTube you can watch them on the go and all those things. And apart from this, still including this all features, and you have some certain new features like real-time video game playing and as well as TV without any interruption, and where like you won't feel like buffering and all these things doesn't at all come into the picture. Okay, so basically basically 2G, 3G, 4G are differentiated based on the networks are differentiated based on um, their architecture and as well as um, their bandwidth, means the estimated bandwidth that actually um, given for a particular user to avoid a service. Okay, so when it comes to IMS, IMS doesn't restrict to strict with um, only 2G or 3G or 4G. IMS has got capability to work with along with any of these technologies, provided the application should also be developed in such a way that if the IMS based application which is developed for 2G technology will work with 2G technology and as well as 3G and as well as 4G. But if it application which is meant for only 4G technology, um, asking for that particular application to be working for um, other technologies is like kind of trying to achieve, which is not going to happen. Okay, so um, what my concern is like while developing the applications, the developer keeps, so whichever the technology based on the type of technology, the application has to be developed and the application should be optimized in such a way that if there is any change in the network, if the quality of the service of the application get reduced um, on the negotiations between the application and the network, or the application and the servers, like IMS servers, and then the decision has to be taken by the network or the IMS network, and then the services has to be provided based on the available bandwidth. Okay, okay. Let's start um, the with 2G technology, anything. Okay, so here UV is there, and UV is connected to some kind of a tower which will be transmitting and receiving the radio signals, and that particular thing is called as BTS, what we call it in 2G, and in 3G we call it as Node B, and we call it as Node B in UMTS. But always remember, from here to here, it is the wireless communication, in the sense like the sending and receiving of the data will be over radio frequency. Okay, but when the data that is sent from UV or the data that has been received at BTS node B or E node B, okay, can be actually sent to the network element called as uh, like intelligence server kind of thing. This is which will be taking care of different multiple nodes, uh, each working in some locations. Say for example, this is in location 1, location 2, location 3. Okay, so all are connected to a particular server, which how these radio receiving and transmitting entities, that it has to communicate with various mobiles that are connected with these towers. Uh, all these things will be controlled by this particular entity, and in 2G it is called as BSC, base station um, controller, and in 3G it is called as RMC. And this particular thing is somewhat in 4G it is more complicated with respect to teaching at this moment. Things like the same functionality is included in this particular entity. So, but we are least bothered about it as of now. But there are some servers that are also available, um, which controls these radio frequency reception and transmission towers, which are connected to mobiles over something called as BSC or RMC. Okay, and okay, till this extent, yes, it is clarified for you guys as well. And okay, now, so this particular thing has got two connections. One is, anyhow, whenever there is any service, whenever there is a call has to be established with some other user, it can be of two different kind of calls. One, you might be calling it from your applications like GTalk, Skype, or Viber, or something like that. Okay, but these all requires some kind of specific settings called as GPRS settings. Okay, and APN should be enabled. Okay, with that. So if this is possible, you will be able to establish the call. But if you have a valid SIM and all, but still you can make calls using normal phone app. Like you just dial a number on your phone, and you just dial a number, and it will be um, going all the way to your friend over on somewhere in the network, uh, okay, and reaches him. So this particular service is called as CS service, and the other services whichever are taken is called as PS service. And CS is nothing but circuit switch, and PS is nothing but packet switch. Okay. So in CS, basically the call, before it gets established, the path is going to be set as a radio link from your UV to a dedicated path with the other end, so that once the connection gets established, it over on the same fixed path itself, the entire communication is going to happen. But whereas in packet switch, like once there is based on uh, uh, the load on the other routers, and as well as the type of packet losses that is happening with respect to your um, network condition. Okay, the routing might get diverted from one router to another router. Say this is router 1, this is router 2. So this happens for PS packet switch. Sometimes it might be going there, sometimes it gets that, and then it goes around this path, and anyhow both are connected to the other end user, other phone. So for example, okay, so this is how it happens. And uh, mm, sessions including the CS and PS, the path will be same for both of them till the BSc or RNC or VNOD when it comes to 4G. Don't get confused with particular things. But till the network level, to some extent, the path will be the same. But they have to take a decision like whether based on the kind of request, whether it has to be sent over on CS path or it has to be sent on PS path. Okay. So this is with respect to the network. Okay. Say for example, if you are browsing or anything, okay, um, you're accessing your office mail or when you are browsing, everything will be going over this particular path from this UV to it will come down to BTS and BTS to BSc, BSc to or on to something called as some networking packet switch networking entity. Okay, so this particular thing, yeah, I'll just clarify this as a GSM, and this is MSc. Okay. So this is the thing. So if you have, so our IMS basically concentrate this particular portion. This particular portion. Okay. When the packet reaches here, and then provided if the operator is kept his server here itself, it will be here, or it might be somewhere outside in the internet, IMS will be there. So this is how it is. So basically IMS is the service that we are going to achieve it only once if the PS is available. And this is packet switch. If we are connected to the GPRS or 3G data, then only we are going to avail IMS related services. Without packet data, we are not going to avail it. So first we have to get registered with the packet switch domain, and if we are already got connected with the packet switch domain, then we can avail the services of IMS. Okay, always remember this particular thing. There, I'll just remove this content, putting whatever it is on top of this. I take a lot of practice. Okay, so now it is very clear for you guys. I hope it's very clear for you guys that IMS works with mobile technology. Okay, and it is meant for the services like voice over IP calls, video over IP, okay, and like video sharing and all, and as well as IM chat, group chat, okay, file transfer, okay. But the thing is, on PC also we are using IP, in the sense internet we are using, okay. We have already internet, okay. And this internet we are connected to PC domain, and as well as we are connected from mobile domain, okay. But the services whatever we have discussed all about, like video call, IM, file transfer, group chat, live video gaming, okay, all these things we have achieved in PC, okay, or using internet, okay. And now the same things we are trying to achieve in mobile, okay. But when it comes to mobile, okay, but to achieve the similar kind of services here as well, okay, it might take a kind of optimization with respect to the network entities, since the mobile related um, things like radio link and all are changing so frequently that mobile is nothing but it is meant for the people who are roaming around and still wants to get communicated with others over on the network. Okay, but whereas like PC like it is, which will be lying over there, which has got a physical cable or router which already fixed over at a location and communicating from one particular point. Okay, so there are a lot of things that comes into the picture to actually availing all these services or on a mobile. Okay, we need a certain kind a new kind of architecture which is called as IMS. Okay, this is like it is like an architecture used for achieving this bundle of services. Some of them I did quite each and every service that whatever we can achieve. These are some. Okay. So using the internet, we are going to achieve the applications uh, like video call and all these things are on mobile as well. Okay, so IMS is the one which will take care of the mobile side, but the protocol, whichever it is used here for establishing the connection with uh, the with the internet to the um, VoIP network or the application servers like file transfer, IM, and all these things. They have used SIP protocol. Okay, the same SIP protocol we are going to use here for establishing these connections with IMS servers. Okay, which are sitting, which are connected to the internet, like how you are connected to the internet. Okay, so uses SIP for establishing the connection. Okay, and we also use SIP. Here also SIP is used. Okay, why we have used SIP over here? Because SIP is lightweight processor. Yeah, it's like request and response based messages, and it's easy for you also to understand at time of implementation what should be expected, and the specs are so clear of RFC326, and it is not stable as well. That's the main thing. So we're going to now slowly get into the IMS side. Yeah. So this is it. It is a lightweight signaling protocol. In the sense, like as I said, it's just a request and response based messages, and the messages are also not so complex that even the beginner level users can also easily understand for the development of an application. So it is very lightweight. So it doesn't have any complex messages as well, and it is a child protocol of HTTP, like for a request you will send a response, and then after that you will send an acknowledgement, so that um, the handshaking gets over, kind of message. Similar way, um, HTTP is also, like SIP is also implemented in the same way. Okay, SIP is one among the protocols that are used in VoIP, because not only the SIP we are going to use. SIP is only meant for signaling purpose. Okay, but actually telling the actual data will be like your voice or your sent messages or anything, blah blah blah. There are some other protocols which we are going to use to carry that particular. Say for example, now if I am in a voice, like VoIP call session, okay, or on a mobile, but my voice data is carried, okay, or on say RTP protocol, real-time transport protocol. But before that particular voice gets carried, first of all, the connection has to be established with other user. So the connection will be established using session initiation protocol. But whereas the voice data will be carried, or voice or video data, any data, user data, will be carried over on RTP. Okay, and there are some other protocols like for controlling this RTP data. Will be using RTCP, means real time real time uh, transfer protocol, uh, control protocol, and these protocols are actually um, are many protocols that are used in while establishing the session right from the beginning to end of the session. Okay, but uh, but establishing and tear down and maintenance, all these things can be achieved using a particular um, protocol called as SIP. Okay, and why we are going to SIP? SIP is not only used in IMS. Actually, it is from a very long time. It is used in IP based networks, like when it comes to the terminals like PCs and all. Okay, so like white phones and all those things. Okay, so SIP is, it's there from very long time, but uh, we have adapted that for our IMS because of its simplicity at the time of development phase, and as well as debugging and everything is very friendly, and that is it. Okay, SIP is basically, we use it for establish, maintain, and terminate a session, like multimedia session, whether it might be video, audio, I mean video, voice, or any other text-based content, any whatever it is, we use the, like um, first of all, I want to get communicated from establish a communication from A to B. Okay, and then after that, once the connection gets established, I want to transfer data from A to B, and once the data gets transferred, once the complete data transfer gets over, or both the A and B gets communication gets over, either A party or B party disconnects the session. So in these particular things, okay, so for example, A initiates a session with B. This particular request, whatever it is sent from A to B, or is called as a SIP message. Okay, and once B accepts that and sends a response saying yes, I am accepting, and all these messages are nothing but also SIP. But whereas once the session gets established, the data transfer between A and B happens with some other kind of protocol based on the type of service you are sending. Okay, I mean like requested. Okay, and SIP nowhere involves in media transfer, only RTP and RTCP will be involved. Okay, that is the main important point. Okay, so this is something about the introduction of IMS. So next we will be going to discuss about architecture of the IMS, that will be in the session 2. Okay. Thanks for everyone. Thanks for watching this video. Please subscribe to my YouTube channel.